Good morning. This is Tim Stewart. I am president at Visual Decisions, and we're here today to talk about how to modernize operational excellence. At Visual Decisions, we've been in the business of utilizing information from the shop floor to improve continuous improvement since about 2002. We help our customers combine the smart factory with the lean factory to drive improvements to cost, throughput, and quality. Our customers have seen dramatic improvements, such as 30% increases in OEE, 50% scrap reductions, and much more. That's why we have a unique approach to work with our customers to adapt processes to take advantage of the new capabilities and help establish a true data-driven manufacturing culture, which is what we're going to talk about today. So as a quick procedural note, if you have questions during the presentation, please enter them into the Q&A. I'll get to them at the end of the webinar. The goal for today is to explore Operations 4.0, how we take existing lean structures and so forth and add Industry 4.0 solutions to those. But I guess what I should cover first is just a real brief introduction to what is Industry 4.0. On the right, that diagram that is probably impossible to read is from the World Economic Forum, and it lists out many different things that are considered to be part of the Industry 4.0 solution set. And what I'm going to do today is I'm really just going to focus on a few of those with advanced analytics, I-IoT, machine learning and AI, and augmented reality. And as we go through those, what we'll see is that the technology alone is not enough. The example of an I-IoT or Internet of Things device that I use all the time is actually a Fitbit. And I've been carrying a Fitbit around for 8 years now, actually. And I've definitely not lost any weight during that time, and I've actually put on a few pounds. And the reason isn't the fault of the Fitbit. The Fitbit works great. It's a great example of an IoT device. It has great sensors in the device. It tracks all my steps, my heartbeat, lots of other things these days. Pushes all that information into a cloud. So you've got a cloud-based application. It has advanced analytics within there that can determine simply from the inputs, whether I'm sleeping or awake in different states and so forth, different types of exercises. And, it has a wonderful, nice graphical interface, mobile interface, web-based interface, etc. And it's a great application. It's a great device, but it hasn't helped me lose the weight. And the reason is that I haven't changed my behaviors. Still, do all the bad things I used to. And so, what we look at with these IoT devices and other technologies for the shop floor is that it's very much the same thing. Just having the technology in place out on the shop floor is not going to make your company more efficient. What you actually have to do is you have to adapt the process to really take full advantage of those technologies in order to see the gains that you want, or to borrow from the analogy, to reduce the waste. And so, as we look to how to really do this successfully, what we have to do is combine the smart factory and the lean factory to drive those improvements to cost, quality, and throughput. So how do we go about doing that? Well, I'll say this: manufacturing has very much embraced technology throughout its history, and continuous improvement has not really kept pace. And so when we look at manufacturing, there's extensive use of automation, robots, cobots, laser cutting, all kinds of different things that seemed futuristic, 15, 20 years ago. And continuous improvement, so many professionals that I talk to in continuous improvement still insist on utilizing whiteboards, manual paste boards, etc. And part of the reason that they insist on that is to get people a deeper understanding, to get, to maintain people's fingerprints on the data, so to speak, so that they keep ownership of, that process and that information. So, as you start to adopt, these technology solutions, how do you go about maintaining those fingerprints on the process? And, part of the solution here is just, utilizing the standard work that's already part of lean manufacturing. And, if we look at something as simple as a visual display versus, a digital visual display versus a manual one, you have the natural involvement with the manual display because people actually have to go to the board and write the numbers down and so forth. And so you build up standard work around people going to that pasteboard and writing down what they've done in the last half hour or hour or whatever it is, and documenting a reason if they miss and so forth. But it doesn't necessarily have to be that you lose that involvement or ownership or understanding, et cetera, when you move to a digital display. You simply build up the standard work that people still need to interact with that information. They just interact with it by actually utilizing it to improve the process as opposed to simply writing it down. And so there's actually opportunities for greater depth of understanding, greater interaction, and much more depth of knowledge by taking that next step, removing the waste of the process and getting to the value add portion. So as we look to transform operational excellence, there's a couple of different sides of this. First of all is the lean management system with standard work, visual controls, management operating system, et cetera. And then the second part is the lean toolkit itself with Kaizen, root cause analysis, value stream mapping, et cetera. And so, as we look through those, if we look at standard work first and, how the digital solutions can help standard work, part of that is just, the information itself. And so how do we get information to people at the right time in the right place in the right format for them to easily take action upon? But then you can build your standard work around having this information available and actually utilizing that now to do different things than you had the capability to do in the past. The other real advantage of the digital solutions and having the digital data collection on the shop floor is that you can actually detect and elevate attention to deviations from the standards themselves, so that you can identify where standard work is not being followed and quickly correct those issues. How does standard work help Industry 4.0? Well, as I gave the fit example, Industry 4.0 solutions provide little value until the behaviors change, and standard work is our primary tool for how we drive those behaviors within the organization. Now, one thing that I'll emphasize here is that I'm not just talking about standard work for the operators themselves. I'm talking about leadership standard work as well. So, how does the quality team go about their work? How does the continuous improvement team go about their work? What do process engineers do on a daily basis? What does plant management themselves actually do on a daily basis and so forth? And so by utilizing the information as part of standard work and having the standard work built around this, we actually now help drive adoption of these different solutions and actually utilize that information now to make real changes. So I gave the example of visual controls earlier, but it's probably worth revisiting visual controls out on the shop floor. This is a typical SQDCM board or safety, quality, cost, delivery, manpower. Some companies add inventory, environmental, other topics to that. But a lot of these boards are done very manually. There's a lot of waste of multiple people going there on a regular basis, updating the numbers, either coloring those things in manually or drawing those things in, writing things on them manually. or printing them off from Excel and coming in and updating the sheets within the little plastic holders and so forth. And then you still have to have people go over there and actually look at the board to take some action upon that. Otherwise, it's just there. And so being able to do this digitally and then still build up the standard work around having people interact with the information on that board to do something with it can provide tremendous efficiencies within the operation, eliminate a lot of the manual processes around getting the information captured and then persisting that information, as well as utilizing the history of that information to identify trends, identify longstanding issues, and then taking action upon those. If you're familiar with a book by David Mann called Creating a Lean Culture, it was a Shingo Prize winning book back in the early 2000s. It's a great book, highly recommended. It does a really good job establishing how you create a lean culture within your organization. But one of the things that he actually criticized in that book was having what he called IT provided visual controls versus the manual visual controls. And I think that a lot of the objections that he raises are the common ones of why you still want to do those things manually instead of digitally. And what I've done on these pages is to really talk about the capabilities that we have around Industry 4.0 and why the complaints that he put out there just aren't true any longer. And so for things like having timely information, having it be accessible, all of those are very much in favor of Industry 4.0. Having the information both precise and verifiably accurate is something that was difficult to do in the past when you were pulling basically ERP reports to post on the shop floor. But with the data that's collected right at the source these days, that's very easy. Does it prompt questions? Part of what you're doing on a whiteboard is that you can only collect very simple information and only display very simple information. And so while, yes, it prompts questions, the problem with it is that you can't answer those from the information that you have on the whiteboard. With the displays that you can put in place and the interaction that you can have with those displays, not only can it prompt questions, but you can also answer them right from that data that's there. Are they easy to change and customize? A whiteboard is going to be easier to change, but the format of these visual controls you can put on the shop floor these days is extremely flexible and can be done. You don't have to have somebody in IT to do it any longer. Operations can control the layout and the information that's displayed themselves very easily. He talks about an intimidation factor, and back in the early 2000s, maybe I buy that, but pretty much everybody interacts with smartphones and everything else these days. Maybe the oldest people within the workforce have this issue, but I would actually argue that for recruiting, younger people into the workforce and so forth, it may not be an intimidation factor for them to go up to a whiteboard, but there's certainly a boredom factor for them to go up to a whiteboard and write that information manually and so forth. Whereas there's not going to be any intimidation factor by looking at numbers on a screen. And so forth. I won't go through all the details here, but certainly I think that a very, very strong argument can be made that we should digitize these things, move away from the traditional manual controls, and have all of these wonderful new capabilities that the digitization brings. If we look at Hoshin Connery policy deployments, management operating system within these organizations, and different flavors of that, management by objectives, OKRs, balanced scorecards, key performance indicators, et cetera, that organizations use on a daily basis to look at how the operation is performing, making sure that you drive alignment from top floor to shop floor, and have everybody pulling on the rope, same direction, and so forth. All of those wonderful metaphors that you care to choose. All of those things can be very easily digitized these days, so that once you have determined what it is that you want to do and so forth, you can easily put that into a system, collect information around that, and actually have people be able to see where they stand, not only on a month-by-month basis or a week-by-week basis, but in real time. Where do they stand against their metrics and so forth? And this can be very, very important for getting people to adhere to these things, actually take action to improve their results and so forth. And it very much helps put the Hawthorne effect in place behind the key metrics that you're using to manage the business. And if you're not familiar with the Hawthorne effect, it's that people behave differently when they know they're being watched. And the relevant portion of this is that when they know that some particular aspect of behavior is being monitored, they tend to increase their performance in that particular piece of behavior. And by tracking the metrics in this way and making those very visible is part of the reason that you have the SQDC boards in the first place. But being able to do it digitally in real time and have that actually add up over the relevant horizon is something that provides tremendous capabilities and tremendous benefits to the organization. And then also being able to track the exceptions, and for each of the exceptions being able to do some level of root cause analysis, and then tracking corrective action plans and the actions and whether it's been completed or not right in the same place gives you very much of a closed loop opportunity or capability to manage those improvements along with where you're visualizing the data. Value stream mapping is another example of something in the lean toolkit where today it's done very manually. This is an example of a workshop that was run by my team many years ago, and very typical of value stream mapping type of an exercise. And it's, at least on the shop floor and the portions of it where you're actually performing activities on the shop floor these days, that can all be done automatically. So as long as we have track, whether it's a work order number or some other label where we can track progress of an item from station to station and so forth, we can see exactly what machine it goes on, how long it takes on that machine, the time it spends between that machine and the next operation, any other movement and so forth that happens to it during that time. So we can see all of the value add, the non-value add activities. We can see the times of those, and we can basically automatically create for the shop floor what this value stream map looks like. If we're collecting data from all the different machines in the process. And this gives us tremendous leverage with our value stream maps, because instead of doing this one at a time for a single value stream where you have to have 10 people in a room and you're putting sticky notes on the wall and so forth, and you're estimating how long these things take, or you're going out to the shop floor and you're spending days collecting data and so forth. Basically, you have all of the products at once. So everything that's going on the shop floor, you can visualize that value stream or those value streams. It's going to be far more accurate and precise. It's going to reflect the true process instead of what people think happens out on the shop floor. It will show all of the process deviations that happen over time and so forth. So as soon as something is deviating from its normal process, I will have visibility to that because I know what the value stream is supposed to be, and I can see that this work order for that item is deviating from its standard workflow. Not only will I see the average amounts of time that something is spending in value add or a non-value add state, I can actually see the distributions and see how much variability I have in those processes and so forth. It can automatically update along with the process so that my value stream map becomes evergreen. It can become part of the daily process. So instead of something that stays on a wall or goes into a drawer, this is something that can actually use as a management tool now to see where those exceptions are taking place, where something is deviating from the process, where it's in a value add or a non-value add state longer than it's supposed to be. And furthermore, again, with the ownership aspect of this, where people are putting the sticky notes on the wall, you may argue that they have more ownership of that value stream. But if I'm collecting that information automatically, displaying the value stream, and then having my people still do the improvement portion of the value stream mapping exercise, where instead of just focusing on the mapping part of it, now we're looking at what are the different steps that we're seeing in the value stream, and how do we actually go about either improving or eliminating some of those steps in order to shorten the amount of time that material is spending in process. Now I still get that understanding of the value stream, I still get the improvement and so forth, but instead of people doing the non-value add portion of the value stream mapping, I have them focusing on the value add portion, which is improving the process itself. Similarly with FMEAs, or failure mode and effect analysis, I have the ability now to digitize this to a very, very great extent, or at least from a process FMEA point of view, and somewhat with a product FMEA. And so when I look at the process FMEA, if I'm documenting the different failure modes and so forth, I can improve, first of all, my probability of detection with these Industry 4.0 solutions by having the additional sensors in place, having the additional information and data being captured, and identifying where I'm seeing those process failures by specifically putting data collection in place to see when that failure occurs. And I can set this up so that I am specifically putting those things in place to detect the different failure modes. And then as I'm collecting data, as the process is ongoing, I will certainly see my probability of occurrence. How often does that failure occur, the severity of that issue, how long is the downtime that it's causing, and then I can supplement that with any safety issues, et cetera, that occur as a result of it. And by doing this, I can keep my FMEA evergreen as well, and utilize this to really improve my process. Now, one thing that I've seen very often with customers is that they'll have done a process FMEA. They'll have, for instance, an OEE solution or something along those lines, collecting downtime information on the shop floor, or MES or something else, and they're not connected. So they've done a process FMEA, they've done a complete failure mode analysis to see, how are the different ways that, this can fail. But when they implement a MES or, OEE solution that, collects downtime data from the process itself, they don't utilize those failure modes as they capture information from the shop floor. If you simply utilize the failure modes that you've identified, what you can do is you can automatically update these things and have that be a live process. And so very important to keep in mind as you're implementing these different solutions, to tie that into how you're actually going to utilize it to improve the process as well. Kaizen, if we think about the Kaizen process improvement process, this is a very typical 6-step process within Kaizen: identifying the problems, analyzing the current process, creating solutions, testing the solutions, measuring, analyzing the results, and then standardizing. Every single one of those can be improved with Industry 4.0 and utilizing data to really drive this process, whether it's identifying where my biggest problems and chronic problems are, doing the root cause analysis, expanding my solution set to incorporate some of these additional capabilities, simulating things before I deploy them out to the shop floor. Measuring the results certainly is going to be something that data will help with, and then standardizing the solution. We talked about how we can have that interplay between the technology and standard work earlier, as well as being able to deploy things in a standard way is something that technology can help very, very much with. And so every single aspect of the Kaizen process should take advantage of these additional capabilities. Root cause analysis is the one thing I never ever get pushback on when I say that it should incorporate more data. Whether you're doing something as basic as looking at failures and asking, did a person cause the failure? What was the actual failure? When is it occurring? During the week and so forth. Where, why, how, etc. Asking why 5 times, doing a fishbone or Ishikawa diagram, looking at things graphically, performing an FMEA, doing statistical analysis of factors, whether it's an ANOVA or a DOE, etc. All of these things are very, very highly data dependent, and the more data you have, the better off you will be. So if we look at root cause analysis and a lot of these other topics, how do you actually go about that? Well, when we look at the data that's required and so forth, and when you should start collecting that data, it isn't once the process has already failed. Ideally, you've already been collecting data. As the saying goes, the best time to plant a tree is 20 years ago, so that it's now fully grown. Just like on the shop, just like that on the shop floor, the best time to start collecting data was years ago. The second best time, by the way, to plant a tree is right now, so that you have that shade in the future. And the second best time to start collecting data on the shop floor is today. But you also have to have a plan for the data collection. You also have to practice proper data hygiene. And so when we look at what data should be gathered, the first question that you have to ask is, where should the data be gathered? And if you have critical processes, if you have a process that is out of control and so forth, those are certainly places to start. Once you've identified where, you can utilize some of those frameworks that we talked about up above to hypothesize about potential causal factors. Process FMEA is fantastic with determining what data should be gathered where. And then put plans in place to collect and analyze the information, and control plans in place to monitor the different factors and so forth. And by the way, the reason that the bagels are there is not to say that zero data should be collected. The reason the bagels are there is that if there were zero cost associated with collecting and persisting the data, you would actually want to collect everything. But since there is a cost, you have to do that prioritization. So where does data originate in the value chain? And the answer is pretty much everywhere. Every single operation in your process, this is a bakery, and I'll revisit the bakery later in another example, but every single operation generates information. Even between operations, you have the capability of utilizing RFID to track the movement of the materials and so forth. And so there's lots and lots of data available to you that's out there. And chances are you have a ton of data that already exists today. So working with a firearms manufacturer in the past, they asked us to create a corporate quality dashboard that they would be able to utilize to do investigations on all kinds of different things. And so we asked what quality data they had today, and they said, well, we don't know, but the IT department thinks it's all in SAP. And when I got done laughing, I said, no, really, where's the data? And so we started looking through, the different systems that they had in place. And, here's a list of some of those different things and so forth, as well as, other items that are related. And for 7 plants, we actually found 57 different systems with quality information in them. They had different statistical process control systems, different test systems, inspection, non-conforming material, et cetera. And so the good news is you probably have a ton of data already to start working that into your operations excellence program if you can do so effectively. And then, as you're thinking about the data collection, how you target it and so forth, just make sure that it is tied into what you want to do from, an improvement perspective, whether that's around TQM or quality management, productive, total productive maintenance, which we're going to talk about next, I think. And, whether it's, maximum velocity, doing lean, keeping things flowing within the factory and so forth. So let's talk about TPM and, lean or TPM and machine maintenance and so forth. And so when I look at TPM, I have the different pillars within here: autonomous maintenance, focused improvement, planned maintenance, quality maintenance, et cetera. And quite a few of those are things that data is going to help with a lot. And so if I look just at how companies keep equipment running today, I'm going to focus on autonomous maintenance, preventive maintenance, condition-based, predictive. I've already covered to a great extent Kaizen and FMEA, so I'm going to leave those 2 alone for now, but I'll focus on the maintenance practices themselves. So from an autonomous maintenance perspective, we're trying to ask the operators to do more and more, all the time as part of TPM, lean, et cetera. And what we're not doing a great job is giving them information that can be utilized at the machine in order to be able to do this effectively. And so we're giving them the responsibility, but we're not empowering them with all the tools that we can in order to have them do the best possible job. And so, as we think about giving them a daily task list of what is needed when, having that potentially be condition based instead of just every 10,000 pieces or every 3 weeks or whatever. Being able to give them very detailed or potentially augmented reality instructions or at least remote assistance for being able to do those things. And very much a lot of different capabilities that we can put in place to help the operators be much more effective with their autonomous maintenance. Similarly with preventive maintenance, for those tasks that the maintenance crew are doing around preventive maintenance, very much like the operators, how do we give them the data to optimize those PM tasks? How do we set up a program where we can look at the interval at which those PM tasks are done and when they're needed to be done versus, how do we optimize that basically? And then how do we give the maintenance people, the best support possible in terms of how to actually perform those PM tasks? And so there's a lot of different things that we can do with the data, how it's presented, and potentially some of those AR solutions in there as well. Condition-based maintenance is certainly something where the more data that you're collecting and the better you are able to identify when maintenance is required, the better off you're going to be, because now you can shift away from doing pure time-based or piece-based preventive maintenance to moving to letting the machine tell you when it needs any maintenance activities. Very much like when you're driving your car, instead of changing your oil every 3,000 miles, if your car could just tell you when it needs an oil change, that would both save you money as well as probably extend the lifetime of the car. And then finally, there's predictive maintenance, which is very similar to the condition-based maintenance, but goes a step further by pulling in multiple different indicators, whether it's sensor, vibration, noise, temperature, et cetera, and utilizing that information to now predict when failures are going to occur. And so rather than having a single thing trending out, which is very much what condition-based maintenance is, for predictive, it may be something where it's looking at multiple different signals, none of which are actually out of tolerance yet. But because of that particular combination, what it's seen in the past is that that's now indicative of a coming failure. And so now you can take action based upon that. So really the key difference for predictive versus condition-based is the sophistication of the model underneath it. So all of those different things are really how we try to address the mean time between failures, and extend the amount of time that we have the machine running between failures of the same type. But once the machine fails, we can also utilize these same solutions to get the machine back up and running much more quickly. So if we break that down into the different steps of how long it takes to respond, once the failure occurs, the operator has to be made aware, and certainly if we have sensors in place and visual controls, we can immediately notify the operator. If we can capture and automatically determine what the failure mode is that has occurred, we can let the operator know that, and the operator can immediately see if that's something that they can address or if they're going to need maintenance assistance. Then we can utilize information capabilities or integration capabilities to make maintenance, engineering, anybody else that would be required for that type of failure mode to be made aware of that failure, as well as contextual information about the type of failure that has occurred and what was happening on the machine when that failure happened. And so they can take the right steps to address that. Someone is assigned, so very much you have workflows within the maintenance department that usually have specialists in mechanical versus electrical issues, just as an oversimplification. And getting that information from the process itself of the failure mode is going to help get the right person assigned to it. That worker has to become available. That doesn't change. Travel to the machine is something that you may be able to avoid if that person that gets assigned can do remote support to the operator to have the operator fix the problem. Then you don't have to have this travel time out to the machine. You can just have them give remote assistance to the operator, have the operator take care of it in some cases, and then you can have the machine back up and running much more quickly. So now maintenance gets to the machine if that's required. Diagnosing the issue. So again, if I can automatically detect the failure mode, I don't have to have the maintenance person, do that work once they get to the machine, and then, actually fixing the issue. And finally, the problem is fixed, or there could be a number of reasons why you have to try again later or have somebody come back out to the machine. And so why doesn't it get fixed on the first try? Well, could be that the wrong repairman was sent, they couldn't diagnose it, etc. And every single one of these can be either eliminated or mitigated by the presence of the data and the intelligence in order to do that diagnosis of the problem. So some very quick examples, and I just have a couple here, but if you're interested, please contact me after the webinar, and I can go through many, many more customer examples with you. This is a large bakery customer that didn't have a whole lot of information when we started off, but we put data collection in place on the shop floor, and then we categorized that information into the area where the failure was occurring, the different categories, the different causes, what product was running at the time, who was running the process, etc. And what we can see is that, at the top level here, we're seeing a lot of downtime every single day, and we've dollarized this to see, what that downtime is actually costing us on a daily basis. And so we're actually tending to lose, $1,000 to $3,000 every day just due to downtime on this one plant. And if we drill into equipment loss and then continue going down, we see that oven is the biggest category within equipment loss. And then looking at the data itself, in most days we don't lose much time on the oven, but then we have these big spikes that occur. And what we determined was that the oven shelves were flipping due to broken pins. So the pins were fatiguing as they were going in and out of the oven. And it was a very simple fix to put a PM program in place that replace those pins on a periodic basis if they were getting fatigued, so that we completely eliminated the biggest source of downtime for the plant, simply what failures were occurring and so forth. Another example is optimizing machine part replacement. So in this example, it's a grinding process that's taking place. And if you leave the grinding wheel on too long, the grinding wheel goes bad and you start producing bad parts. If you replace the grinding wheel too often, then you're spending excess money on grinding wheels. And in this operation, they were spending multiple hundreds of thousands of dollars on these grinding wheels on an annual basis. And so what we did was, we collected information from, the machine PLC, as well as additional sensors such as vibration, noise, power consumption, other time series data. And we fed that into ThingWorx, which was the IoT platform that we were using at this customer, and put the different elements in place within there. And so as we're collecting data from the process, we can see what this looks like when the wheel is worn. We can see what it looks like once it fails, and we can see what it looks like for a new wheel. And so we were able to identify where you can start to predict that that wheel has an imminent failure coming. And so we basically, once we started to see this, get to a certain point, we can predict that we need to change the wheel. And we utilize a prediction model to be able to do that using several different parameters. And then we made that information available to the operators through a web interface, as well as mobile alerts and mobile apps and so forth. And optionally, you could do this with augmented reality and other things to help them take the steps to actually now replace that wheel and so forth. So I'm running long on this, so I'm going to go through this very quickly. But this can have tremendous impacts to the operational and financial performance. What we do in Visual Decisions is to generate a top-down benefits case first, looking at what are the major buckets of improvement that you could identify for the business, what's most important to you. Drill down into why those things are happening. What are the different root causes for the current performance? And then we start to identify what are the enablers and the capabilities that can directly address those root causes. And by putting not just the technology in place, but what process change needs to happen, now we can start to mitigate those root causes and generate the business outcomes that we're looking for. And so just a few of the operational improvement metrics that you might look at: total cost of quality, throughput, maintenance or tooling costs, reducing inventory, compressing time to market, capturing new revenue streams, et cetera. And certainly there's tremendous links to the financial performance as well. We've identified many more impacts on typical income statement or P&L than what's listed here, but these are some high-level categories that get impacted. And then we also run or This is from the World Economic Forum, and their estimate of impacts on performance, whether it's productivity, speed, et cetera, from some of these different implementations. Closing thoughts. Typical roadmap that we utilize with our customers is mapping out the vision first. If you already have a roadmap, that's fantastic. We can help you identify how you can leverage your existing infrastructure and data on the shop floor in order to be able to achieve as much of that vision as you can without implementing any new technology. The next step is, for those gaps that do exist, what is the best way to fill those capability gaps, whether it's IoT solutions or machine learning or whatever it might be. And then integrating across different processes. The example I give all the time here is warranty. You don't want to look at just the warranty data itself in isolation. You want to be able to look at what was happening on the shop floor when those items were produced. Take that back into the design process and do full design for Six Sigma process and so forth. To identify, where can you make improvements, whether it's in the design of the product, how you're manufacturing it, or how you're deploying it out in the field that are going to help you with those warranty issues. But keep in mind throughout the whole process that you have to transform the culture and the process to take advantage of those capabilities that you're putting in place. So the workshop that we run is a diagnostic to help you identify customer needs, target problem areas, and quantify the identified opportunities, define a roadmap with clear timeline and deliverables, and develop plans to deliver gains within the first 6 to 12 months. And there's a lot of value in doing these workshops in terms of getting everybody together to do these things. And with that, I want to thank you very much. This was a little bit longer than I had anticipated for today, but hopefully you enjoyed the content. If you would like to talk more, please reach out to me at tim@visualdecisions.com or reach me at my phone number there. I'll probably either have myself or one of my people follow up with everybody that attended and try to see how you're doing these things within your own business, and if we might be able to help. So once again, thank you very much for your time today.